So what will happen here? If you can remember what we did yesterday, so yesterday we did the same thing about the quadratic equations, but we discussed that one with the vertex form. Here it's not like that. Now we are going to do the same thing about the quadratic equations, but it's totally about the standard form. So this is the second form of the quadratic equations. Now, for the standard form means if you check on these ones, we'll be focusing on the identifying quadratic functions in standard forms, determine the vertex, domain, and the range, axis of symmetry, maximum or the minimum values, and x-intercepts and y-intercepts for quadratic equations. These are kind of few things which we are going to learn about during this section. If I move to the theory, so here we are going to learn about the standard form. When it comes to standard form, what do you mean by, what do you think? How we gonna, can you tell me the standard form of an quadratic equation? I think you have already know the equation.
ax square plus bx plus c.
Yes. If it's the standard form, then that means function of x is equals to ax squared plus bx plus c. This is what we have called standard form. So earlier we had the same quadratic equation with the vertex form. Now we are using the same quadratic equation with the standard form. Okay. So the first part, they are asking model the path on a football. So they have given a scenario like this. They ask us to find out the 1 minute. What will happen here? They have given us kind of an scenario and they ask us to model it for an quadratic equation. First, we'll do the theory part and then we'll try to model the given scenarios for these quadratic equations. So for the part B, investigate a quadratic function of the form fx is equals to this one. So here we have the standard form. That is fx is equals to ax squared plus bx plus c. That is the standard form. Now what will happen? So the path of a, okay. First you just read these two. I mean the whatever they have given us to model, depending upon the situation, the punter may kick the football so that it will follow a specific path. Work with a partner, draw a coordinate grid on a sheet of grid paper, label the x-axis as horizontal distance, downfield, and the axis as height. How do the horizontal distance and height relate to the kicking of a football? On the same grid, sketch out 3 possible flight paths of the football and describe the shape of your graphs. Are these shapes similar to other students' graphs, and describe the common characteristics of your graphs? So what they have asked us to do is they just ask us to model the path of the football. The football might have various paths, multiple paths, so that we have to consider all those paths and draw the entire path of a football. So we are going to discuss about the standard form of quadratic equation by using that scenario. No? Then the path of a football through the air is just one of many real life phenomena that can be represented by a quadratic equation. For this, we can apply this quadratic function. What will happen here? A quadratic function of the form fx is equals to ax squared plus bx plus c is written in standard form. If a given quadratic equation, we called a quadratic equation is a polynomial equation which the degree is 2. So if that one already written in this format, ax squared plus bx plus c, then we can say it's in a standard form. Is it clear?
Yeah.
Using technology, graph the quadratic function. You can directly apply these kind of functions and draw these graphs. So they just ask us to using technology. So let me open a graphing tool here. Okay, graphing calculator, and we'll draw this one. 1 minute. Graphing calculator. Okay. For this graphing calculator, now what is the equation? Y is equals to minus x squared okay, y is equals to minus x squared plus 4x plus 5 plus 4x plus 5. So here we have the graph of this equation. Okay, since it's minus x squared, the coefficient of the a value is negative, then it will be open to the downward. Okay, now let's see, is it clear up to this point?
Yeah.
Okay, now let's see, describe any symmetry that the graph has. Okay, what would be the symmetric value? What would be the symmetric for this graph? So
X equal
any
to
x equals to, yes, x is equals to 2. And then the 11th one is, does the function have a maximum y value? Does it have a minimum y value? Explain. How we gonna explain that one? So since here we have a,
maximum.
yes, here we have a maximum value, which means y is that the value a is negative. Negative in the sense here it's upwards to the down, open to the down, which means here we have a maximum value. Okay. Then what else? The 12th one, using technology, graph on a Cartesian plane the function that result from substituting the following c values into the function of OK. Now what will happen? Okay, these three, it's clear, right? How to
Yeah.
explain these ones? Okay.
Yeah.
Now we are doing a new question. The new question is, now here what is happening? They have given us the standard form quadratic equation with the constant c. Now they ask us to draw three diagrams, three charts, actually three graphs when c is equals to 10, c is equals to 0, as well as c is equals to minus 5. Let's draw that one first. Okay, so here we have the first value, minus x squared plus 4x plus, here we have first one is 10. Okay, then the next graph would be 0. 0 means there's no any constant. Then the third one would be a negative value, minus 5. Minus 5. Okay. These are the three set of first question. We have minus x squared plus 4x plus c. So c will be either 10, 0 or minus 5. Now what will happen here? So these are the three graphs which we have. What do you think of this? What do you think? So this one is the minus x squared plus 4x plus 10. Here we have the minus x squared plus 4x, the blue color one. And the green color one, we have minus x squared plus 4x. 4x minus 5. So, what do you think? What has happened to these ones?
Minus moves it down and plus move up.
Yes, yes. So, if you draw this minus x squared plus 4x plus 10, from that, if we wanted to derive this, the second function, which means the same graph, but what has happened to that one? It has been shifted down from 10 units. So if you check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This red color, the same function, the red color function has been shifted down by 10. Okay. From this one to this one, here we have minus 5. Minus 5 means, again what has happened? Again we have to shifted this blue color graph from 5, okay, from 5 units down. Is it clear what has happened? So from here to here, the difference is 10. So from here to here, the difference is what? 5. From this C value, that's what it has happened. That's the thing we need to carefully look at according to the C value, how the graph changes. Is it clear?
Yeah.
Okay, so if we draw this first one, minus x squared plus 4x plus 10, so this one is the maximum value. No? So here we have actually plus 0, right? Plus 0 means the C value, if you compare the C value, 10 units have been reduced. So which means, see, here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this red color one to blue color one, 10 units have been reduced. Okay, is it clear? From the
Yes.
blue color one to green color one, only 5 units have been reduced. So here,
Oh,
from here to here, 1, 2, 3, 4, 5. Because here we have 0, here we have minus 5, which means 5 units have been reduced. So the entire graph has been shifted down, entire graph has been shifted down by 5 units.
oh,
Okay? Okay. Now the next one is, so that's about the C. So that's what happened when we change the C value, which means the constant value accordingly. Is it clear? Then the
yeah.
next would be, if I take another new graphing calculator, okay, there what they have done, now we are going to change the A value. Now we are going to change the A value. The same equation, but we are changing the A value. Let's see. So the first equation what they have given is minus 4. Okay, sorry, y is equals to minus y is equals to minus 4x squared minus 4x squared 4x plus 5. This is the first function that which they have given us. Then the second one is, so we drew this one, minus 4x squared plus 4x plus 5. Then we have the second function that is with the minus 2x. See, minus 2x squared plus, look at this, minus 2x squared plus 4x plus 5. Only change what we do is for the value a. The rest of the x term and the constant, it's still remaining same. And then we have the third one. Third one is 1x squared. 1x squared means actually x squared. X squared plus 4x plus 5. See, x squared plus 4x plus 5. Then the second one would be, fourth one actually. Fourth one is 2x squared plus,
Minus.
yeah, 2x squared plus 4x plus 5. Now tell me what has happened here. These are the four graphs. Here we have the red color one. Okay. Here we have the blue color one. Then the green color one is x squared plus 4x plus 5. And then the purple color one is 2x squared plus 4x plus 5. What do you think what has happened?
The bigger the A value, then it gets more compressed. More big.
If it's a value, okay, a value anyway we can conclude whether it's whether this entire graph is concave up or concave down, which means it's
Yeah.
open to the up or down killer. We can consider from that one. And from this value itself, so here we have minus 4, here we have minus 2. Minus 4 one is the red color one, minus 2 one is the blue color. What has happened there? When the value increased, the graph is getting more wider or narrower.
Oh,
The red color one is the first one, minus 4x squared plus 4x plus 5. Red color one is this one. Blue color one is minus 2x squared plus 4x plus 5. This is the blue color one. What do you think?
so
It's getting more wider, right? From this red color one to blue color one, it's getting more wider, as well as what has happened here. The maximum value also changed.
yeah.
Everything changed. My maximum value changed, and the symmetric axis of the symmetric also changed. Everything changed, but what we can define is from the A value, we can check from the A value, we can decide whether this entire graph is concave up or concave down. The rest of the things, it will change. Is it clear?
Oh, yeah.
But it was not like that for the previous one. Previous one, we just changed the C value. We just changed the C value. Okay. The rest of the A and the X term, I mean X squared term and the X term was remaining same. So because of that, when we change this entire function with the constant, that means it will be shifted up or down accordingly. But it's not like that. When it comes to A, the entire graph will change, but only thing we can get is if this value A is a positive value, then it concave up. If this A value is a negative value, then it will opens to the down. Is it clear?
Yeah.
Okay. Then the third one would be, the last part would be, now we are changing the B value. See, now we are going to change the B value. Okay, let me get another one. Harit. So now what has happened? So now what has happened for the third one, that is y is equals to minus x squared. Okay, the graph is, let me copy this one, and I just paste here. Y is equals to minus x squared plus bx plus 5. Here we are changing the b values. We are changing the b value means 2, 0, minus 2. The first one is 2. Okay. And then the second graph is when this b value is 0. Then the third graph is when this b value is minus 2. Okay, minus 2. Then the fourth one is minus 4. Minus 4. These are the 4 charts which they have given us to compare. 2 when the b value is 2, 0, minus 2 and minus 4. Is it clear? Now what has happened here? Oh, okay. It's kind of a very complicated one. See what has
Yes.
happened here. The red color one is the minus x squared plus 2x plus 5. So here we have the minus x squared plus 2x plus 5. So all the a values are negative now, which means all these graphs are concave down. That's fine. Now we are only comparing with the b value now. So in the red color graph, the b value is plus 2. The blue color graph, okay, the blue color graph, the b value is 0. Okay. Now the
Um,
green color graph, the blue value is minus 2. Okay. Here we have the minus 2 with the minus 2 one. And
yeah.
for the last one, which means the purple color one, there we have the, what we call, there we have the the b value was minus 4. What do you think what has happened here? Any comparison? Any
Shift
comment on
left.
these graphs?
Shift left.
Yes, yes, yes. Shifted left. If it's minus 4, then the graph shifted left. If
Wait, what if it's plus 4? Goes the other way. Minus x squared plus 4x plus 4. Goes the other way.
minus x squared plus 4x, if it's minus x squared plus 4x, see, then it would be in the right side. That's how it is. So if it's minus x squared plus 0x plus 5, which means, so it's actually symmetric. The symmetric line is y-axis, right?
Yeah.
See the blue color one? Blue color one is the middle one. So that's how it is. Is it clear now what is happening here?
Yeah.
And also all these ones. So if you check for this one, all these graphs are intersecting the y-axis on the same place. So that value is actually 0, 5. 5 is the coefficient. See, 5 is the coefficient. So all these graphs are intersecting the y-axis where? That is 0, 5 at the coordinate of 0, 5. Okay, is it clear?
Yeah.
Oh,
Yes.
okay. So we'll move
Wait,
forward.
the graph is also getting big too. Like it shift to the
Yes, yes, yes. So here, if it's minus values, then it will be shifted to left. And if it's right, if it's a positive, value, positive b value, then it will be shifted to what we call, it will be shifted to right side. And if we change this c value, okay, if I change this c value, let's think that I changed it as 10, then see, it has been shifted. It has been shifted up from 10 values. So here we had 9. Oh, minus x squared. Here we have minus. No, not 10. Actually, it's shifted from 5. So here we had 5. 5 to 10 means increased 5 values, which means here it has been shifted up from 5 values. Okay? The black color one and this red color one, is it clear? So here we have this x squared plus 4x plus 5. So minus x squared plus 4x plus 5. What has happened here? I just changed the c value. Only the c value. C value, I just changed it to 10. 10 means 5 units have increased. 5 units have been increased means all these y values has been shifted up from 5 values, 5 units. That's how it is. So that's what the black color one and this red color one interpret. Okay, is it clear?
Yeah.
Okay. Now reflect and respond. So now what they are saying, what do your graphs show about how the function fx is equals to ax squared plus bx plus c is affected by change in the parameter c? Okay, what has happened here? If we change the parameter c, the constant c, it has
They
been
move up
shifted.
and down.
Oh, okay, shifted up or shifted down. Yes, move up or down. If the c is a positive value, then it will shifted up or move up. If it's getting decreased, which means it's a negative value now, then it will be moved down. Okay, that's correct. How is the function affected when the value of a is changed? If the value of a is changed, then what has happened? Only
It
thing is,
stretch. It get narrow or what?
yes, yes, concaved up or concave down. We can conclude whether the graph is kind of a open upward one or open downward one. Yes. Then the 17th, what effect does change in the value of b? If we change the value of b, which
Shift
means
shift left to right.
shift left to right. Yes, that's how it is. Now we are going to link these ideas for the theories. So see, the standard form of a quadratic function is fx is equals to ax squared plus bx plus c, or y is equals to ax squared plus bx plus c, where a, b and c are real numbers with a is not equals to 0. As I already told you, this coefficient a, the constant a should not equals to 0 Why? If it's equals to 0, then this is not a quadratic equation because this entire term will be cut. Then this will be converted to a linear equation. Because of
What?
that, uh,
You
yeah,
said it'll be converted to cot.
y is equals to ax squared plus bx plus c. So this value a should not equals to 0. If it's equals to 0, what will happen? Then a is equals to 0 means there's no any x squared term. No? Then this entire equation is converted to a linear equation. It's not an quadratic one. Okay, is it clear? If this
Bx plus c is like mx plus c.
yeah, y is equals to, then it will be y is equals to bx plus c. This is actually y is equals to mx plus c type of an equation. So
Yeah.
here this is degree 1, a polynomial with degree 1, that is a line, not an quadratic function. If it's a quadratic function, then the degree should be what? 2. The maximum uh, x value should be x squared. The power, maximum power should be x squared 2. Okay.
Yeah.
Now, then A determines the shape and whether the graph open upward, positive A, or downward, that is negative A. B influences the position of the graph. C determines the y-intercept of the graph. That's how it represents. Okay. You can expand. Okay, now what we are doing here is, so this is what we had as a vertex form. Can you remember? Y is equals to a times x minus p squared plus q. This was our vertex form quadratic equation. Now the standard form quadratic equation is y is equals to ax squared plus bx plus c. Okay, these are the two forms which we have already learned so far. Now what we are going to do is we are going to find a relationship in between these two parameters. These two parameters of two forms, either the vertex form as well as the quadratic forms. So to do that, actually what we are going to do now, we are starting from this vertex form and then we just remove this quadratic, we just remove these brackets. Then we will be received a times x squared minus 2x plus p plus p squared plus q. So this is what we received after removing the brackets of the vertex form of the quadratic equation. Is it clear?
Yeah.
Now, so this format is actually what we have as ax squared plus bx plus c, no? Because a is here also we had a. As b, here we have minus 2a p value. C means actually ap squared plus q. Is it clear?
No.
So from the vertex form, we can get the standard form as well again. By comparing the two forms, you can see that the value B of the standard form is equals to minus 2AP in the vertex form. But don't recall these ones. Don't by heart these ones. It's better if you can work these ones quickly and get the answers at the exam. Because if you by heart these points and then apply, surely you will be, it will messed up. The best thing is get the logic, then you can do any kind of a problem. Is it clear? So here from the standard form, we have the value b that is equals to the vertex form minus 2ap. Here we have the p value is equals to this one, c value there they have equals to this one, then they have get the expression for q value as well. Likewise, if we have the vertex form, we can get the standard form. If we have the standard form, we can convert that one into the vertex form. Is it clear what I'm saying?
Yeah. How is it equal like that?
How was it equal like that?
How does how do you
Yeah,
know
because
C?
so here we have the x squared terms. If these two are representing the same function, if these two are representing the same function, which means these two functions should equals to, which means x squared terms, coefficient of x squared term should equals, which means a is equals to, if we compare the x squared terms, then we have a is equals to a. If I compare the x terms, then we have, okay, minus 2ap is equals to b. Okay, from this we can have the value b as minus 2ap. If we wanted to get the value for p, then the p value will be b over 2a, b over 2a minus. Is it clear? Then we can compare the coefficients, I mean the constants. If we compare the constants, then we have, so here we have ap squared plus q is equals to c. That's how it is. Okay, is it clear?
Yes.
Okay. Example 1. Now, okay, can you do this first one? So what you have to do, identify the characteristics of a quadratic function in standard form. So they have given us the standard form equation, and then they just ask us to comment on these features: the direction of opening, coordinates of the vertex, maximum or the minimum value, equation of the axis of symmetry, x-intercepts and the y-intercepts, and also at last they have asked us to comment on the domain and the range as well. Do the first one and the last one, this one and the fourth one. I'll take some more time now.
Kill a soldier, which is genuinely insane. He exposed fallible, and that individual is Ty Recker's Lowell. You know, the creator who made this. The frozen miner. Yeah. Now, recently, Ty Recker's Lowell has made multiple videos on fallible Lowell. I honestly feel like this one sums up the situation. So,
Okay, what do you think for the first one? Fx is equals to x squared. So what are the comments? Okay, do. First one and the D, A and D. Okay. The first one, direction of opening. For the A, direction of opening,
Upward.
upwards. The coordinates of the vertex,
0, 0.
yes, the origin. Maximum or the minimum value?
0, 0. Minimum.
Minimum value. The equation of the axis of symmetry,
X equals 0.
x equals to 0. That means y-axis. Then, yes, then x-intercepts and the y-intercepts.
I
Do it
only
have
can find.
x-intercepts?
No.
No.
How about 0, 0?
0, 0 is, yes, you can take. And what about the y-intercepts?
Only 0, 0.
Yes, yes. Then the domain and the range?
Domain is like X is all real numbers.
All real numbers. And the range also?
Range is like Y is greater than 0.
Yes, positive real numbers, right? All the real numbers, but positive real numbers, yes. What about the D, graph D, fourth one?
Why don't do that?
Mhm.
How do you
Okay.
find vertex?
Vertex.
Yeah.
So vertex is this point.
How do you find it? Like,
How to find?
number.
You can read that value. So the x coordinate will be 3. Okay. And what about the y coordinate? I feel like the value will be, if I check for this one, it's in the, yeah, it would be 7.5 or something. When the x value is 3, when the x value is 3, y value is 7.5. Okay. Then it's also a direction of opening upwards. Coordinates of the vertex 3, 7.5. And you can put the x coordinate here and get the exact y value. You can, so if you can't read that exact value from the table, from the graph, what you can do, you can read the x value. No, x value is exactly 3. Then you can substitute this x value here and get the y value. Okay.
So,
So from that,
how?
you can, yeah.
Wait, what do you say? Like, 0?
0 means?
You said to find the vertex, you can plug number.
Vertex means this one, or the minimum point, the turning point. No? So the turning point, so the x coordinate of the turning point is 3. So what you can do, you can substitute, instead of this x, we can substitute the value 3 and find out the y value. Y value in the sense we can read this value. Is it clear?
Yeah.
Yeah. Then you can find out exactly the y value of this vertex. I mean, y coordinate of the vertex. Okay. And then the coordinates of the vertex. And there we have again minimum value. And the equation of the axis of symmetry, x is equals to 3, right? And the x-intercepts and the y-intercepts, do these have x-intercepts? Do this curve
No.
has, no, there's no any x-intercepts, but for the y-intercepts,
Yeah.
yes, you can substitute the value x is equals to 0, and then that value would be 25. Okay, 0, 25 is the coordinates of the y-intercept. Then the domain and the range. Domain,
X is all real number and y is greater than
y is greater than the minimum, I mean the vertex, y coordinate of the vertex, right? If you find that one, it should greater than this value. Yes. Now it's clear for you. See here, the vertex value is 7. If you check for the value, it would be 7. And here, how to define the range, that is y is greater than or equals to 7. Then y should be in real numbers. Okay. You should provide all the answers in this manner, in this way. Okay.
okay.
Okay. Then you can do these examples, your turn, homework. And there we have the example 2 as homework solution. Okay. Then they have given the solution as well. You need to go through with these ones. And here again, we have a question, homework. And then the example 3 again. Okay, shall we do one example? Yes, we'll do one example. Shall we do this example 3? Try to do this example 3. That is the only theory that we have for the standard form. Standard form. So just try to do this entire example 3. If you are stuck at something, then that's fine. You can refer for the solution they have given and complete. If still it's not clear, just ask from me. Try this example 3. We will move to the next section after this. Okay. Write a quadratic function to model the modular situation. A rancher has 100 meters of fencing available to build a rectangular corral. Write a quadratic function in standard form to represent the area of the corral. So then there should be, if it's a rectangle one, there should be length as well as width. Okay. What are the coordinates of the vertex? What does the vertex represent in this situation? And they ask us to sketch the graph for the function you determine in part A, determine the domain and the range for this situation, and identify any assumptions you make.
Rectangle.
Yeah.
How's your quadratic function? What's
Why? So here we have a, okay. So rancher has 100 meters of fencing available to build a rectangular corral. So as they have drawn here, we have to have a rectangle. So the length would be L and the width would be W. Then the entire area would be what? That is, area is LW, the multiplication of the length and the width. That's what here we have. Then, so now what has happened here? The first part is write a quadratic function in standard form to represent the area of the corral. No, so now what do we have here is, so they have given that the fencing available to build a, okay, has 100 meters of fencing. 100 meters of fencing means actually what? So if you get the circumference of this entire one, because we are fencing to the circumference now, then there would be 2L plus 2W is equals to 100, the entire length. From that one, we can have another expression, that is L plus W. Okay, L plus W is equals to 50. L plus W, so L plus W is equals to 50. Now here we had an expression called A is equals to LW. We can replace this L or W from this expression, because if we want to remove L, we can use L is equals to 50 minus W. Is it clear? If
Yeah.
you wanted to keep the entire equation with length, then you can remove this W, which means the width. If you remove width, which means you need to substitute W is equals to 50 minus length, likewise. Is it clear?
Yeah.
Then you can generate a quadratic equation. So the quadratic equation is A is equals to, if it's in W, which means if it's in width, you can use it as A is 50W minus W square. Okay. That's fine. Try to figure out.
So you turn the length into width into 50W
Yes.
square.
Yes, yes. Length is equals to 50 minus W. Length is equals to 50 minus W. See? Then we can rewrite this area of this entire rectangle, that is L into W. No? L means 50 minus W. 50 minus W into W. That is 50W minus W squared. Okay?
Yeah.
Okay, then what they're asking, sketch the graph for the function you determined in part A. How do we gonna sketch this one?
Right.
Okay, before that we need to provide answers for B. What are the coordinates of the vertex? what does the vertex represent in this situation? Now the equation is minus w squared plus 50w is equals to a. Then what would be the vertex? A means y, no? Y is equals to, so here this one is the function. Minus w squared plus 50w. This is the given function. From this function, how can we find out the vertex?
It's equal to b minus b over 2a.
Yes, minus b over 2a. You can
Is there
substitute
other
those.
way to do it?
Hmm?
Is there other way to do it?
Other way. No, what you can do is you can use the completing squared method as well if you wanted to find, but still so far here they haven't teach that method. No. Did we? No. Oh, yeah. So because of that, we can use these formulas to find out the vertex. It would be the easiest way. So x is equals to minus b over 2a. So minus b means minus 50. Minus 50 should divided by 2a means minus 2. Minus 2 times 1 means minus 2. The answer would be 25. Okay. Then you can determine the respective y coordinate as well after substituting 25 to the given equation. Okay. That is for the B. Try to sketch the graph and do the part C, D, and E as well. Am I too fast? Am I too fast? No? Tell me once you are done. You're doing right?
Yeah.
Okay. Sketch the graph for the function you determined in part A and determine the domain and the range for this situation. And finally, identify any assumptions you made in modeling this situation.
The 50, I have to draw the 50 W square minus W.
Which one?
The 50 W square.
Yeah, 50 W. So yeah, the equation is y is equals to. So the equation is y is equals to. So generally we had the equation as a is equals to 50W minus W squared. If I convert this into y's and x, a means actually y, W means actually x. Then the equation, proper equation will be y is equals to minus x squared plus 50x. This is the given equation, proper equation with x's and y's.
Oh. Wait, do.
Do? Okay. No questions, right? Is it clear?
Oh, yeah.
Okay. Do I wanted to do all the solutions are given so that you can refer the solutions as well. Yeah, we'll otherwise it will take some time, no? So now as homework, you need to do these ones, your turn questions. Okay, that's all for the standard form 1. So the key ideas in section 2 is the standard form of a quadratic function is what? Ax fx y is equals to ax squared plus bx plus c. Okay, or else fx is equals to ax squared plus bx plus c. And remember, a should not equals to 0. So the graph of a quadratic function is a parabola. As we already know, we called a special name for these curves. Those ones are parabolas. The graph of a quadratic function is a parabola that is symmetric about a vertical line. It's symmetric about a vertical line if it's a function. And also it's called the axis of symmetry. So for this symmetric line, we called it as axis of symmetry. That passes through the vertex, and also as they have given this entire vertex axis, sorry, symmetric axis, it passes through the vertex. Opens upward has open upward and has a minimum value of a, that is a is greater than 0, and if the curve is open downwards, then it has a maximum value, which means a value is a negative value. And also has a y-intercept. The value of the intercept point would be the c. I mean the x coordinate is 0 and the y coordinate is c. Is it clear?
Yes.
So you can determine the vertex, domain and the range, direction of opening, axis of symmetry, x-intercepts and the y-intercepts, and maximum or the minimum values from the graph of a quadratic functions. So if they ask you to explain the graph, you should be able to provide the explanations for all these points. That's how it is. So they have given us a summary as well with 2 graphs. And then to find out the vertex, I mean the x coordinates of the vertex point, that is minus b over 2a. Okay. So once you found the x coordinate, you can substitute this x coordinate to the given function and find out the relevant y coordinate of the exact y coordinate of the vertex. Okay.
Using this, you can find the vertex.
Yeah. So we can find the x coordinate of the vertex only now. Once we
Yeah, but
find
then
the x coordinate, then we have to again apply that value for the equation.
why?
Yeah. And then we need to find out the y coordinate.
Oh,
So
okay.
for quadratic functions in applied situations, the y-intercept represents the value of the function when the independent variable is 0, and also the x-intercept represents the values of the independent variable for which the function has a value of 0. And then the vertex represents the point at which the function reaches its maximum or the minimum, and the domain and the range may need to be restricted based on the values that are actually possible in the situation. These are kind of few facts. If you can explain these graphs properly, then that's fine. Okay. And then you have another exercise, check your understanding. So there you have so many questions. You should try out all these questions up until this point. Homework. So we'll start with the third. So we'll start with the third one as well. It's also easy. That is about the completing the square. Okay, give me 1 minute. I'll bring some water and come quickly. Now what we are going to do here is completing the squares. So if I explain you simply, now this is not needed. No, let me close these ones and this one is the new one. Now the third one would be 3.31, that is completing the squares. So what do we have? As they have already said, we will be focusing on converting a quadratic functions from standard to vertex form. If the quadratic function is given in standard form, which means we have the quadratic equation like this: ax squared plus bx plus c. Now we are going to convert into vertex form. Okay, so let me show you simply how we gonna convert this into a vertex form. So the given function is y is equals to ax squared plus bx plus c. Then our first task would be, we have to make this x squared coefficient as 1. Okay, the x squared coefficient as 1, which means we can take this a out. Okay, and then we can rewrite the rest of the terms. That is x squared plus b over ax plus c over a. Is it clear? I make this coefficient of the x squared term as 1. Is it clear?
Yes.
Now what we have to do, then now we are making it as a complete square. To make this as a complete square, first we need to take 1x from here, 1x from here. And then here we have b over a. For the x term, we take half of this one. We take half of this one, which means plus b over 2a. I just took half of this one. And then I'll make this as complete square. Okay.
How do
Now,
you turn B?
uh,
How do you get 2A?
2a. We have to take, that's why I'm showing you. Wait. So we wrote, this is not the complete one. Okay. Now I just what I did was I just consider the middle value, middle coefficient, actually the coefficient of the x term, and I just took the half of it. Okay, and then make it as a complete square. Now what I'm going to do here is, if I remove the brackets, and if I remove the brackets and simplify it, I received, you can see that I received x squared plus b over 2a times 1, and again we need to multiply it by 2, no? Then we have b over ax plus b squared over 2a squared. That means actually b over 2a squared. Is it clear? What we have if we remove the brackets and simplify of this x plus b over 2a term? You just write out x plus b over 2a. If you expand, if you remove the brackets and expand, what will you receive? Tell me. What will you receive?
Oh,
So you
yeah,
receive this one, right?
yeah. I thought I got 2xb over 2a. Then you simplify over b.
Yeah. Now what will happen? You can see here we have the x squared. Okay, x squared term is there. See, x squared term is there and b over ax also there. But because of this complete squared thing, we are getting kind of an additional term. B over 2a complete square. So what
Yeah.
we have to do, then we need to remove that additional term from this one. Okay. And then we need to add this last coefficient, what we had earlier, that is C over A. Is it clear what I did? So I just removed this this additional part, that is the complete squared of this second term, b over 2a complete squared, and then from the top, from the previous stage, from the previous step, we had c over a no, at the end. So I just added that one as well. If you simplify this entire equation, you can see that you will receive the same equation what we have here.
So there's an extra b over 2a you want to remove. Okay.
Sorry?
So there's an extra b over 2a. So you subtract.
Yeah, I just subtract. Yes. I just subtract y. I just subtract y. So because of the squared of this term, we are receiving an additional term, which was not there in this initial equation. B over 2a complete squared was not there in the initial equation. So initial equation we had a times x squared plus b over ax plus c over a. So because of this squared, because of this making squared, we are getting kind of an additional term. So what we need to do, we need to subtract that additional term. It's
Okay.
not clear? Are you sure it's clear? Okay.
Yeah.
Then the last part, that is C over A, will be there. And now, so this is what we call the completing squares. So if I write, okay, wait. If I write this properly, now we have the equation as y is equals to, so I'm multiplying these entire values from A. So A times x plus b over 2a complete squared minus, now we have, okay, now we have, if I write it as plus, I just take this last term first and then I'll write b over 2a's complete squared, and then we need to multiply this whole thing by a as well. That means y is equals to a times x plus b over 2a squared plus then a times, here what do we have? C over a minus b squared over 4a squared. Okay, if you simplify further, a times x plus b over 2a complete squared plus, then we have c minus b squared 4a. Now, this is what we had earlier as well. This is the vertex form of the, this is a vertex form of an equation, right? Quadratic equation, because as we learned, we had that one as y is equals to a times x minus p squared plus q. No? This is what we have. So q means actually c minus b squared over 4a. P means minus b over 2a. Is it clear?
Yeah.
Can you do this one by yourself? Start from this standard form, convert this standard form equation to the vertex form now. Do it by yourself. Start with the standard form equation, and then that's what we have to learn for the entire 3.3 section. So if you are clear of this, if you are clear with these steps, no problem, this entire section is covered. So what you have to do, you have to start with the standard form. Okay, you have to start with the standard form and then do convert that standard form into the what? This vertex form by yourself. Okay, start. රිප් එක ගන්න කලින් රවුල පා ගන්නනේ.
How did this step come?
Sorry?
The C over A minus B.
Hmm. Okay. Yes.
How did this step?
How that step comes. Okay. So how it works. So we are starting with y is equals to ax squared plus bx plus c. Now what will happen as the first step? We'll take this a out. What we need to do, we just make the coefficient of this x squared term as 1. So here this one will be x squared plus b over ax plus c over a. Okay. Now what will happen? We are making this as a converting this into a complete square. So how? We just use 1x from here and then half of this middle term, that is b over 2a. 2a is complete squared. So here we have the remaining part is plus c over a, but there's an additional term coming from this because of this squared. So there's an additional term that is b squared over 4a squared. So since this is an additional term, we need to subtract that term from this given equation. Okay, is it clear what I did there?
Yeah.
So once you, if you remove these brackets and check, so you are getting the last term as b squared divided by 4a squared. That was not there in this second step. So we need to remove that part. That's why here we are getting b squared over 4a squared to subtract. Okay. Now to make it a proper vertex form equation, then we need to multiply this one by a. So a times x plus b over 2a squared plus a times, here we have c over a minus b squared minus 4a squared. Okay, then that means y is equals to a times x plus b over 2a squared plus, here we have c minus, because I'm multiplying this a from each value in here, c minus b squared over 4a. This is the vertex form. So we started with the standard form and we make it into a vertex form. Is it clear? If you have any questions, just ask from me. That's totally fine.
How do you get the minus b square 4ac?
Minus b squared. This one. Which one?
Minus b square 4a square.
Yeah, that's what I'm saying. That's what I'm telling. So here you make it as a complete squared. No? Okay. Here you make it as a complete squared. Now what will happen? If you remove these brackets, okay, see x plus b over 2a squared. If I ask you to remove these brackets and simplify, what you will receive? Tell me the equation which you received. If you remove these brackets and expand these brackets,
X
what you
square plus
x squared plus
uh, uh bx over
bx over
2a.
a. Then
Bx over 2a.
ah ah. So here we have okay b over 2a squared, right? This is the third term now we are receiving here. So for example, let's assume we have x plus 5. Okay, on x plus 5 squared. X plus 5 squared. How we normally expand this one? So that is x squared. Okay, x squared plus I just multiplied these two and again need to multiply it by 2. So 5x into 2 means 10x and then 5 squared, right? 5 squared means 25. That's how we get this 25. So now see, on the previous step, we had only x squared plus b over ax plus c over a. There's no any term called b over 2a complete square. I mean b squared over 4a squared they don't have. It doesn't have. Is it clear? Because
Yes.
because of that, I just removed this additional term from the square. See, I
Yeah.
just removed that additional term from the squared. So this c over a was there in the previous step and then I removed b squared over 4a squared. That's how we received this b squared over 4a squared. Is it clear now?
Yeah.
Okay. That's what we normally do as what? That's what we normally do as how to convert the standard form quadratic equation to a vertex form. Okay, if I move to the unit, I mean lesson, investigating completing the squares. Okay, now what they are doing, so they have just asked us to do kind of a practical situation. They just ask us to part A, comparing different forms of a quadratic function. Yeah, it doesn't matter, that's fine. And we'll move to this one. Okay, so what we have here is okay. Okay, okay, okay. Okay, the first one would be kind of an practical one. If I go to the theory directly, link the ideas. Now what we are going to do here is, I'm just moving to the theory. Then you can try it out that practical thing later. So the theory would be, now we have already learned, okay? So read, you can express the quadratic functions in standard form. So we learned the standard form as ax squared plus bx plus c. Or in a vertex form, that is, we already learned the quadratic equation with the vertex form as well. There we have a times x minus p squared plus q. Okay. Now what will happen? You can determine the shape of the graph and direction of opening from the value of A in either form. The vertex form has the advantage that you can identify the coordinates of the vertex. Because of this vertex form, directly we can identify the coordinates of the vertex. But if we are using the standard form, we have to find a method, or we have to convert that standard form into a vertex form to find out the coordinates of the vertex. But if we have this vertex form equation directly, then we can find out the vertex coordinate of the vertex directly. Is it clear?
Yeah.
The vertex form has the advantage that you can identify the coordinates of the vertex as PQ directly from the algebraic form. It is useful to be able to determine the coordinates of the vertex algebraically when using quadratic functions to model the problem situations involving maximum and the minimum values. Now what they are going to do, they have started this entire thing not with the standard form. They have started this with an example. So see, the given standard form equation is y is equals to x squared minus 8x plus 5. So what are the steps we need to follow? If we wanted to convert this standard form equation into a vertex form equation, quadratic equation. So first,
60 and subtract 60.
Yes. So what we have to do first, we need to group this first two, which means x squared minus 8x. The 5 will be remaining. And then here, so what we have to do, so the half of this middle term would be 4, no? Then squared of that 4 means 16. So what we do normally, we just add 16 here and subtract that 16 again. Because of that, we are not changing anything from the initial equation. So x squared minus 8x plus 16 is x minus 4 complete squared, and the remaining part is minus 16 plus 5. Then we have minus 11. If I normally do this one, how I normally do, let's start. So here we have the equation y is equals to x squared minus 8x plus, then we have the 5. Okay. So the easiest method is, so we just, so the coefficient of this x squared term is 1. Then we just take 1x here. And then half of this middle term, that is minus 4. Half of the coefficient of this value. Then I'll close this bracket and make it complete square. So the remaining 5 is still remaining. Okay. And then here, if we remove this bracket and expand this, you will receive x squared minus 8x plus 16. 8x plus 16. So there we have an additional term that is 60. So what we have to do, we need to subtract that 16 from here. Then we are receiving the final form of the vertex form, that is x minus 4 complete squared plus 5 minus 16. There we have minus 11. So this is the format, this is the vertex form of an equation. We start with the standard form and then we convert it into a vertex form. Is it clear?
Yes.
That's what they have also done. Okay. Now, if I show you, so that's what here they have given. In the above example, both the standard form, this one, and the vertex form, this one, represents the same quadratic function. You can use the both forms to determine that the graph of the function will open up. Since a is equals to 1 anyway, it will be concave up, which means it will be open to up. However, the vertex form also reveals without graphing that the vertex is at 4 minus 11. Then if we have the vertex form, then from that vertex form of that equation, we can see that the coordinates of the graph will be 4 and minus 11. Then we can easily draw the graph. Is it clear?
Yes.
Now you have to do all these examples. Rewrite each functions in vertex from by. Okay, try these three. First one, x squared plus 6x plus 5. And then the second one, 3x squared minus 12x minus 9. Then the third one, minus 5x squared minus 70x.
I do B. How do you do B?
Yes. You wanted to do B. Did you do the first one?
Yeah.
Okay. So the answer is correct.
Is the 8x plus 3 square minus 4? Like that.
Okay, let me show you. Y is equals to x squared plus 6x plus 5. Okay.
Yeah.
Now, so what will happen? Y is equals to, we have to consider 1x, x plus half of this coefficient, that is 3. Okay. Complete squared plus 5 is remaining, and the additional value is what?
Minus 9.
Yes,
Minus.
yes, minus 9, which means here, if we simplified further, x plus 3 squared minus 4 is y. This is the vertex form.
Oh.
Okay, then the second one, I'll take a new paint and show you. Second one is y. I'll just replace this fx from y. Y is equals to 3x squared minus 12x minus 9. So here, first thing we need to do is we need to make
B.
the no, we need to make this we need to make this x squared coefficient as 1. No, because of that we have to take this 3 out. Okay, if we take this 3 out, then the remaining part is x squared minus 4x minus 3. Okay, is it what you told? So then what you need to do, now you need to make this complete square, this one. So here 3 will be remaining, and then x minus half of this 4, that is 2 squared. Here we have minus 3. Minus 3 I'll put again here, and thus we have to subtract the square root of this term, that is 4.
Okay.
3 times x minus 3 squared minus 7. So which means 3 into x minus 3 squared, I just multiplied, minus 21. Okay? Is it clear?
Yeah.
Do the
Wait,
third
how
one
is
as
x minus 2?
no, 21. 3 times 7, that is 21. I just removed this curly brackets. 3 times 7, that is 21.
What if the number right in the middle you cannot factor?
Which one?
Like if the middle is like x square minus like
Yes.
like
So, okay. So, just expand this vertex form one. So we can again expand this one. Check. We can again expand this one and check whether we receive this format. No. So if I start with y is equals to 3 times x minus 3 squared minus 21. Now what will happen? 3 times, okay, x squared
isn't
minus,
x minus 2? It's supposed to be x minus 2, right?
sorry, x minus 2, right? Okay, that's what you are saying. Okay. x minus 2. Sorry. Here it should be x minus 2. Yes. So here it should be, that's what you are saying, right?
Yeah.
Okay, x minus 2. Yes. Then x squared minus 4x plus 4. So we can close this bracket, minus 21. Now we can check the answer, 3x squared minus 12x plus 12 minus 21. That is, we have 3x squared minus 12x minus 9. Okay? So that's what we have. It's clear, right?
Yeah.
Okay. Then, okay. So you can, so you already done these ones. No, they have given the answers as well, solutions. Okay. Algebraic method and the algebra tiles. Okay, no need those ones. If you can use the algebraic method and do, then that's totally fine. So use an algebraic method, that one also we did. Okay. Now here we have your turn. You have to do these ones as homework. And the example 2, convert to vertex form and verify. Okay. So, okay, your turn. Can you do this question? Convert the function. Okay, this question. So convert this function into a vertex form and then verify that the two forms are equivalent. To verify, what you need to do, you should draw these two graphs and verify, or else you can work backward as I did. You can work backward and check whether you received the standard form of that equation same. Okay. Are you clear with the steps you need to follow?
Yeah. Now, what if it's like a very odd number, like x squared plus 3.5x? That's hard to find, like
Then it
that.
would be halves. Halves in the sense you have to use those ones as fractions. See, this one, 4x squared minus 28x minus 23. No? Now see, we have to take this 4 out. If we take this 4 out, which means x squared minus 7x. But now what they have done here is they have only take this 4 out from first and 2. Okay. Then what they have done here, half of this 7 is 7 over 2. No? Then x
Yeah.
minus 7 over 2 squared. Okay. And then they have add the square root of 7 over 2 and then subtract 7 over 2 square. Minus 23 will be the left. I mean left in the sense it will be remaining same. And then they just simplify. That's fine. If you have kind of odd numbers or something, then you have to consider it as half. 7 over 2, 9 over 2, likewise.
Wait.
Okay?
Yes.
Okay. Now follow those steps. Okay, this is the question. Your turn.
I got
Yes?
like -3. Mhm.
Okay. -3, then you should take that -3 out.
I got -3x plus 9/2.
Okay, let me show you. That's easy. Y is equals to, here we have -3x squared minus 27x plus 13. Then here we'll take this -3 out. Then we have the rest of these ones, x squared plus 9x plus 13. Yeah, it's not actually plus, it should be minus, right? Minus 13/3. Because from that only, if we multiply this -3 by -13/3, then only we are getting this plus 13. Okay.
Yeah.
Now, -3 times x plus 9/2. Complete square. Minus 13/3 minus, then we have 81/4. 81/4 came the square root of 9/2. Okay. Then -3 x plus 9/2 squared minus, I'll take, what do we have? I'll consider this 12 as a common denominator. Then 4 times 13, then we have 52, right? Yeah, 52 minus, then we have 3 times 81. Then we have 243 or something. 243. Yeah. So then we have, actually you can multiply these ones by -3 as well. That's also easy. Okay, that's fine. -3 times, here I have x plus 9/2 squared minus, altogether we have 7, then 9, 2/4. Because I just multiply this -3 from this entire one. Then you will receive 297/4. Is it clear?
Yeah.
Okay. So, which means you are pretty much clear about that. Then you can do, to check whether this is equivalent to the, whether these two equations are equal, then what you have to do, you have to backward this entire one. Then you can simplify that one. Okay, you can check whether that one is equal. Okay. Okay, that's it. Then you can do these ones, homework. Okay, the same things. Your turn. This one also as homework. And here we have the additional equations. Your turn, key ideas. Okay. Can you complete this entire 3.2 and 3.3 sections? Because up to this point, we have completed chapter 3. So which means, so now we are done with all the theories now. So you can do this homework thing and this, tried out all these examples, at least go through with all the steps, follow all the steps. what they have done here. Then your turn. This one is an question for you to do homework, and then they have given the key ideas. Only thing we learned here is to convert the standard form into a vertex form. Okay, that's what we learned here. Then this entire exercise would be homework. Check your understanding. Okay, and then you need to complete the entire chapter review as well. There you have, I think, exam styles questions and stuffs. So you can complete the chapter review. I mean, chapter review question as well. The entire chapter 3-1. So here you have the multiple choice questions also. These ones also homeworks, which means we are done with the third question, third chapter. Okay. So you have so many homeworks to do. Then again, chapter 4 will be quadratic equations. We'll see, okay, graphical solutions and the quadratic equations. We'll continue with the fourth one next day. That's fine. Okay. So you have to complete the entire third chapter. I already sent you, right? This entire book.
Yeah.
Okay. Then you can try all these workings at home. Then, yeah, we'll continue the fourth chapter next day. That's fine. Okay. Okay. Thank you so much for joining. Have a great day. See you.
See you. Bye.
See you. Bye.